this should be working. It's like my first video. Mainly because I just want to just want to post something. This is pretty fun, so I'll post this then. Yeah. So let's do this then. So I'm gonna start maybe number 1 looks pretty good. Pen doesn't work. Shoot. Oh, even pen actually doesn't work. There it is. Okay. I think I've seen this question before, actually. Yeah, I think I've seen number 1 before. Is it recording right? Yeah, I'm pretty sure I have seen this before. I'm still gonna do it, but it's kind of, I have seen it before. So type is one word, different letter, each letter word we want. So yeah, first of all, we want to establish just base cases. So we have A, B, C. If we have, let's say, in this thing here, we have the position modifier to try and find the invariant here. So let's say here, say the sum of P is equal to 0. And then if we perhaps move this there, we have A, C, B. So this is 0, because it's the same, it hasn't moved. And this one is +1, or actually early, so 1E. This is 1 late. They cancel, so P is equal to 0. What's more interesting to look at is, I guess, the degrees of freedom we have here. So we have A, B, C. So you can see that each letter of the word will appear exactly once. No, sorry. Yeah, sorry. They will occur at most 1 letter late. So the position that A can be in is either can be there or there, where C can be there or there or there. So we can see that we have 1 degree of freedom, 2, and just that there. Then we have 3 degrees of freedom. Oh God, I cannot write, it's quite late. So we can see here that we have so first A, B, C, and then we have B, A, C. So we can swap that around. This when we hold A constant, we move B up. There's another one. And then we have A, C, B, and then we have C, A, B. So we kind of see there's a case forming, and I guess we do it for 4 as well. Yeah, if we do it for 4, I think this will be better than doing an invariant approach, I think, hopefully. So again, if we do 4, A, that's 1, then we have B, A, C, D, it's also 1. Oh yeah. Then we have, I was thinking of the case, but then I can't for that. Anyways, this is A, B, A, C, B, D. We have A, B, no, sorry, C, A, D. We have A, B, D, C, A, D, B, C, D, A, B, C. As you can see, kind of, there's already a pattern forming. So we have 1, 1, 2, 1, 1, 2, 3. So I'm gonna say it's gonna be in the form of something. This is n is equal to 4. Yes, for this one actually, so n is equal to 3. So let's call a function let n be number of, what do you call it? Number of arrangements. My cat, I think. But yeah, so you have that f here's 3. F3 is equal to 2, plus 1 plus 1. Then we have f4 is equal to 3 plus 2 plus 1 plus 1. And for f5, let's try it. It's not really a very elegant solution, but we are getting a solution, perhaps. And so we have B, A, C, D, E. A, C, B, D, E, C, A, B, D, E. What else? Oh, C3, A, B, D, C, E. A, D, B, C, E. D, A, B, C, E. And then I'm gonna say that there's gonna be 4 combinations here because it's quite. There's definitely a general rule that's being followed here. So f5 is equal to 4 plus 3 plus 2 plus 1 plus 1. And actually, hold up. If I say that this is equal to 5, 6, 7, and that's equal to 4. It's equal to 4 plus 3, 5, 9, 11. Yeah, I think. Oh, something like I saw something like this before, like a Fibonacci. If we say this is might be a bold claim, could we say that f n is equal to f n minus 1 plus f n minus 2, perhaps? That might be bold. That might be kind of like presumptuous. Should we induct? I'm not sure. I'm not sure we should induct. There's definitely channel cases. Yeah, I'm confident in this actually. But so yeah, so if you want to try, how many is this? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So we have f9. 9 is equal to f8 plus f7. It's equal to 7 plus f6 plus f6 plus 5. And what do we know? We know f5, right? Yes, get on to f5. That's no goodness. Wait, that's from this too. So let me draw. So by 2, let me say 6 plus like a square. f6 is probably 15. Let's say. So f6 would be 16. Sorry, but it's just f5 plus f4 plus f5 plus 2 f5 plus f4 2 f5. You can group this so we have 5 f5. I think I messed up. No, I can't. Oh my god, I idiot. Sorry. I just don't know how to use this approach. I might just. I know it's gonna be some. Also, this is cool, yeah, but. What could this be? I'm so tempted. So we're going up, right? is not very vigorous, I will say, but f3 equal to 4, f4 is equal to 7, f5 is equal to 11, can I just say, actually, sorry, not in B. See that fn is equal to f1 plus n minus 1? Perhaps, is that? I think I jumped on this too quickly because I think I recognized it, like this pattern from somewhere. Let's see, well, f3, so f3 is 4, and this holds for like n greater than n to 2, because 2, 1, 2 is kind of a weird case, okay, but solve for this, and then 16 you can probably, like f6, x and 4, and 5, 16, 16 equal to, and f16 is equal to f5, f5 plus 4, no, f5 plus 4, ooh, f5 plus n, sorry, it's too late, yeah, 5, 11, no, shoot. Yeah, it's definitely the structure, yeah. Sure, f16, I'm gonna check f6, actually. A, B, C, D, E, F. So we know that we have 1, 1, 2, 3, 4, 5. Then we have 9, 16. So F 16. This might be it actually. Yeah. This. F7. Yeah, this is it. Yeah, FA. Pretty sure. Okay, well, I can work it out. I guess for F equal to 9, this equals to, sorry, n minus 1. Just think, you know it now. Fuck, I had it there. Shoot. Then. I swear I had it. Plus 5, plus 6, 2, plus 7, 39, plus 8, 37. I don't know. I'm quite sure the answer is 37. But till I prove it, I don't know. As of yet, come back to that one. That one looks good. 4. 4 looks, I don't know, looks like deceptively evil, or simple, sorry. 4. n is 2n plus 1 is equal to k squared, or k, I guess k could be integer. Okay, so from the offset, just looking at parity, I think is best to look at it first. So we know that 2 to the n is even, and it's not too much news. And then times n, whatever n, is still going to be even. So 2n plus n, 2n even, and with n, 2n plus 1 to odd. So this is going to be an odd prime number. So we can say k is equal to j plus 1. Or, yeah. J is an even number, an arbitrary even integer. So we have that n dot n plus 1 is equal to j plus 1 squared. So n by 2n is equal to j squared plus 2j plus 1. N by 2n is equal to j squared plus 2j. And n by 2n is equal to j plus 2. Okay. So j is even, it's good. So j can be composed maybe. Or perhaps this could be nice actually. J plus 2 for n, that's a power of 2. So so what do you find here? J is even, okay. Even, yeah, so it is even, regardless of n, which makes sense. How do you look for a bounding maybe? N equal to 2j over n. So we have that 2n is equal to j squared over n plus 2j over n. So I guess, I don't know, could say that n j is equal to n divided by j, or n divided by 2. Okay, I think, yeah. Now for n to divide 2, so for this case here, that means 2 n, and n is a positive integer, so n is equal to 1 or 2, perhaps. No. 2, 4. Why could it be 1, 4? Why could it be 1? What am I missing? Of course, well, if n is equal to 1, then 2 to the n, that would be 2, so then j squared would have to be like, oh, possible actually, because j is an even number. Multi-even, which means j is not odd, so let's be, sorry, not j is not 0, sorry. So j, minimum j has to be 2, so then 2 over 2 plus 2. Right, 2 that's not 2, so yeah, it can't be 1. So one case n equal to 2 then. And checking that, we have 2 times 2 to the 2, 8 plus 1 squared, perfect. Or j divides n. So if j divides n is equal to n, not n, it's a bit weird. Y, so we have j is equal to n gamma, I guess. We have actually, could do is j over gamma plus n. So we have that 2j divided by gamma is equal to j squared plus 2j over j divided by gamma. We have 2j to power j, sorry, 1 over gamma is equal to j plus 2 over j, so over gamma. These cancel, so what are you left with? You're left with 2j 1 over y gamma, sorry, is equal to gamma j plus 2. So what do you find gamma to be? Gamma can't really bound anything with gamma, really, as of right now. Perhaps we gamma both sides, power of gamma, sorry. And we have 2j is equal to gamma, j plus 2 to the gamma. This is true. Goodness. For this to be true, right, gamma has to be even. First of all, so we'd look better for you like this, perhaps. Gamma, so we is this gamma approach is gonna work? I don't think. Good luck. sorry, j squared divides gamma. Yeah, I mean, to be fair, j squared is divide gamma, and then j must divide gamma. Oh, the number theorem is so long, so rusty. J plus 2. And could this go tomorrow? I think it's kind of late. I really. Let's see if one problem solved. I will get back to this tomorrow, I think. I'm sleepy. Bye.